Hello, welcome to today's class again. Look at this challenge we have before us here. Our bracket open minus 5 close bracket to the power of x equal to 5. What there is the value of x here? Definitely, if you look at this question, we cannot have real root from this challenge here. So definitely we're going to have only imaginary roots. So how do we solve for the imaginary roots? So let's take our solution here. All right, so the question is minus 5 close bracket r to the power of x equal to 5. All we just need to do here is to rewrite this expression we have here now. This could be written as bracket minus 1 times 5 r to the power of x equal to 5. Now, we have to bring something to represent our minus 1 here, either using the Euler identity or using the square root of minus 1. I could as well use the Euler identity to represent this, okay? Because we know that if we use the Euler identity, this is going to give us our e to the power of pi I, right? Times 5 here. Okay, but let's use the simpler format for this. So remember that our square root of minus 1 is equals to our iota. So if we want to remove this, we square both sides of this equation. So this will give us minus 1 is equals to iota square. So we can replace our minus 1 with iota square here. So this is going to give us here, bracket your iota square times 5 r to the power of x equal to 5. Easy. Okay? So at this point, what we do here, we just have to ln both sides of the equation because we're looking for x. So for here, we're going to have here ln bracket I squared times 5 r to the power of x is equals to the ln of our 5 in here. Easy. So what we do next again, we look at this. We can apply the law of logarithm, which says that if you have your log, let's take p to the power of k, move this exponent backward here. Okay, so this will now give us here k, the log, this is times please, p here. Okay, so let's apply that here. We have to move this to this side of the equation. So this is going to give us our x, the ln bracket iota squared there times our 5 close bracket equal to ln of our 5 here. So what we do, again, we have another property here, okay? So, but before then, we were looking for x, so let's divide both sides by ln of whatever we have in here. Okay, so if we divide, it's going to give us here this all over bracket iota squared times 5 close bracket all over our ln of our iota squared times 5 close bracket. This leave the system. So we now have our x will now be equal to the ln of our 5 close bracket all over the ln of our iota squared times 5 close bracket. Now look at this here. We are going to call the multiplication law of logarithm. So we can apply that to this. What does that law say? It says that if you have our log, your n, then this is equal to log our m, then plus log our n. Remember this law? Yes, so we can apply that to this expression we have in here now. So let's continue on this side here. All right, so apply that law. This will give us here our x will now be equal to the ln of our 5 here. Then all over. So this is going to give us here the ln of our iota to the power of 2. Then plus the ln of our 5 in here. Again, we can apply the law of exponent logarithm. Okay, law of exponent of logarithm. So this will now give us here our ln of 5 close bracket all over 2, the ln of iota, then plus ln of our 5. I put this in bracket, put this in bracket. So this is the value of x that will satisfy this equation. Yeah. So if you learned something from this video, however simple it may be, give the video a thumbs up. This is OnlineMaths TV, and my name remains Jackson Emo. Remember, I love you guys. I'll be there all the time. Thanks for the encouragement. Bye. Until we see you in our next class.